This is chapter 4. Chapter 4, which is systems of linear equations and inequalities. Now, what is a system? Before, on the previous chapter, we learned about linear functions. Now we learn about systems. So first, let's discuss about a system. A system, based on the textbook, is the open sentence, each of which contains the same variable. So if this is an example, I will give you example that if I have a line, a linear function, for example, y equals this one, and I will present it in a graph. This is the graph. This is a linear function. Okay, this graph, this line will be the solution of these functions, right? They are showing all other pairs which satisfy this function. And then if I have another function which is linear, y equals to x minus 1, and I will present it on the graph like this one. This is another linear function, a different one. And this blue line, it represents all ordered pairs that satisfy this equation, which is all solution for this function. Now, since these two lines, they are speaking in a sentence of two variables, they are in one system. So the system for this part, this example consists of two linear functions, two lines. Okay, this is a system. Solving a system, which is what we are trying, this is our objective for this chapter. Solving a system means we're finding the coordinate of the intersections of all functions inside the system. So actually this linear and this linear show that they have different ordered pairs, right? So this and the blue lines, they share different ordered pairs except this one. On this certain point, okay, which is the intersection, they are sharing a same coordinate, a same ordered pair which satisfies both equations, both functions in the system. So solving the system again means finding the coordinates of the intersections. Okay, we are trying to find what pair of x and y which satisfies both equations, both functions. And the first method that we usually use is by referring to the graph, right? So since the graph is obvious, so this is the intersections. So the coordinate of the x and y, you can just find what is the x and what is the y value. But for this example, as you can see, we cannot find exactly what is the value. It's not -1 for the x, it's not -3 for the y, it's more than that. It must be in fraction or decimals. Therefore, to find the accurate value of this coordinate, if this is your case, we cannot use the graph. But if it is obvious, if it's obvious on the graph, you can just directly show what is the solution of the system. But for this part, we need to find it with calculation, which is in mathematical language. So now, let me give you another example. So if this is the case, okay, let me just get rid of this. If this is the case, so in the system, we have three linear functions. We have three lines. This is in one system. And to solve this system, it means that we need to find the intersections of all of these three functions. Again, the intersections of all of these three. So in this system, as you can see, the intersection between the red line and the blue line is at this position. But the intersections between the blue lines and this line will be at this one. But the intersections between this line and this line will be around there. Yeah, it's far away, but they will intersect each other. So based on definitions, the solution of this system must be the intersections of all functions in the system. All. It means this system doesn't have solution. since we don't have intersections of all three linear functions. So this one has no solution. But if we have different case like this one, so the system consists of three linear functions, and by solving the system means we're trying to find the intersections of all linear functions involved inside of the system. It means the solutions is here. This is the solution of the system, which is the coordinate of x and y at this position. So we have a solution, just a solution. So you can figure it out that if we are just focus on the linear equations, if it is involve only linear functions, the solution must be only one, except we have other cases, but usually we have only one. Okay, so for example, if this is the case, like this, if we have three, right? And if this is the situation, we don't have solution, since we don't have the intersection of all three functions. I hope you get the idea here. And we want to find what is the coordinate exactly, what is the solution of the system, by using two methods, which is linear combination and substitution. If we cannot solve a system by graphing, since we cannot find the accurate coordinate just referring to the graph, let's do that by calculation. I will show you two different methods, which is the first one is the linear combinations, which combine the elimination and substitution that you have already learned from the previous grade. So first we use the elimination to find one of the pair, which is the x or the y, by using elimination. After we find one of that, we find the other by substitution. So please do not be confused with this one, since I cannot delete this. So we will go to that one. Just ignore this, okay? So now let me show you one example. If we have these two linear function, okay, this is the first one, 2x plus 7y equals 5, and this is the second one. There are two different functions in a system. So we have two different linear functions in a system. And please keep in mind that linear combinations work best on the functions that use this form, ax plus by equals c. Okay, so if we have ax plus by equals c, I prefer to use the linear combination. Now, how to do the elimination? Again, since we try to find the ordered pair that satisfy both equations, it means we use these both equations, eliminating each other to find what is the value of your x and y. So now, the first step is I want to eliminate the x. I have to make both coefficient of the x the same. If I want to eliminate the y, I need to make both the coefficient of y the same. So for this one, I will show you how to eliminate the x. Okay, so I want to eliminate the x. It means I need to make both functions have the same coefficient. For this one, it has 2, the first one. The second one, it has 6. It means I need to make both equations have the same coefficient by multiply the first function by 3. Okay, so we multiply all of this by 3. And then I have this one. So 2 times 3 is 6. So we have 6x plus 21y equals 15. So all of it, we multiply it by 3. And then the second one, yeah, you can get the hint since it's been there for a while. So we multiply by 1. Okay, so yeah, we don't change anything since we multiply it by 1. So we have 6x minus 2y equals 15. So we are complete in this first step. So I have both equations have the same coefficient of the x, since I want to eliminate x. So it is 6, this is 6. Done. The next step is we eliminate the x. Since we have both coefficient positive, so I will eliminate it by subtraction. So I will subtract both functions. And then we have, this is the result. So the 6x minus 6x equals 0. 21y minus negative 2y. So it becomes 21y plus 2y equals 23y equals 15 minus 15, 0. Okay, so using the multiplication property of equality, I will have that the y equals 0. Remember, y equals 0. Okay, I want you to understand that it doesn't mean that it has no solution. It has a solution, but the y equals 0. Okay, so let's move forward. Since we have known the value of the y, now we need to find the x. Since we are finding the solution, which is the coordinate of the x and y, right? So after we have this one by elimination, of course, the second option is finding the x by using also elimination. But now, since we are using linear combination, just use the other method, which is substitution. So we substitute this value that we have already had, which is y equals 0, into one of these. So you can pick either the first one or the second one, and then you substitute 2y by 0. But this one, I will use the second one. 6x minus 2y equals 15. So I substitute y by 0, and then I will find what is the x. So in the end, when I simplify it, I will have 6x equals 15. And then let's use the multiplication property of equality. I multiply both sides by 1/6. In the end, I will have x equals 15 over 6. So you can simplify it into 5 over 2 or 2.5. So we have found one solution, which is the only solution for this system, which is a coordinate. So I want you to keep in mind that the solution form will be s equals, well, all solution will be in braces, and then in parentheses, since it is a coordinate, 5 over 2 comma 0. That is how you write the final answer. It means the intersection between this line and this line is this one. Or this coordinate, this pair, will satisfy both equations. So if you substitute 5 over 2 to the x and 0 to the y for both equations, it will make both equations true. Now let's use the other approach. Before I use linear combination by eliminating the x first. Now I will show you with the same example, I want to eliminate the y first. Okay, of course, we have to find the same final answer. It has to be consistent. So now, let me just show you the same example. Okay, this one. Okay, as you can see, it's the same with this one. So the first thing, I want to eliminate the y. It means is I make both equations have the same coefficient of the y, or the same amount. The sign can be different, but let me show you to make it clear. So first, I will multiply the first one by 2, the first equation. So the result will be 4x plus 14y equals 10. And then I will multiply the second equation by 7. So I have this equation. So since the coefficient of the y regardless the sign, okay, has the same one, 14 and 14. Okay, now I can eliminate the y by using addition. Okay, I use different approach here. So if I add both functions, I will have 4x plus 42x equals 46x. 14y plus negative 14y, it becomes 0. So we have eliminated the y. Job's done. Sorry. And then we add 10 plus this one equals this one. So after that, we can find the x by isolating x, and you can use the multiplication property of equality. So we have the value of the x, which we can simplify into 5 over 2. So after we find the x, by eliminating y, the next step is we substitute the x into one of these function. Sorry. So let's substitute 5 over 2 to one of this. For this one, I will use the second one also. Okay. Please keep in mind I can actually use the first one, but for this example, I use the second one. So I substitute the x into the second one. So the next, after I simplify it, I have 15 minus 2y equals 15. And then I simplify by subtract both sides by 15. In the end, I have this one. And yeah, of course, it's just arithmetic. And we have the y equals 0. So in the end, we will have the same solution, which is this one. Look. So you can use either approach, whether you want to eliminate the x first or you eliminate the y first, they will both consistently show the same final answer. Now for the second method, we are using only substitution. So before we use the combination between elimination and substitution, now I will show you how to use just substitution. Okay, for just elimination, you can get the idea. So for elimination, after you find one of the one answer x, so you do the other elimination y, but that's not suggested. So I suggest you, if you use the linear combination, use elimination by substitution and then substitution, or just substitution. For the second method, which is only substitution, I always prefer this one, but this is subjective. If I have the system shows you the linear functions in the slope-intercept form, I prefer to use substitution. But again, for this one, we can use elimination. Okay, just use the same idea like before, but for this part, I want to show you how to use the substitution. So in this one, I have two equation, okay, and this one, and then I want to find what is an ordered pair which satisfy both equations. I want to find the intersections of both equations. I want to solve the system. Okay, so by using substitutions, since it's already been defined that the y equals this one and the y equals this one, and the value of y that we are looking for will satisfy both equations, it means I can substitute the definitions of the y from the first one into the second. Okay, so you get the idea. So since the y equals to this one, then this y I can substitute by this definition. Therefore, by substituting that, I will have this one. So I will substitute the first one into the second one. So I will have the y substituted by negative 3 over 5x minus 4. This one. This replaced the y. So the y equals 2x minus 1. I hope you get the idea there. So we have this statement that we can find the x by isolating x. So for this part, I will show you just the complete step. So I will add both sides by 3/5 x, and then after that we have, yeah, it's the same thing. So after I simplify it, I will add both sides by 1, and then I will multiply it. So in the end, you need to know that the objective is isolating x. So the value of x will be equal to negative 15 over 13. So after I find this, okay, after I find this one, then I will substitute the value of x into one of these equation. Okay, this one and this, or this one, to find the value of y. Since I know that y equals this or y equals this, and I have found the value of x, it means I just substitute the x into one of these to find the y. So at this example, I will use the second one, y equals to x minus 1, since it's simpler. I avoid to use another fraction there. So we'll substitute the value of x into one of the equation of the functions, and I will substitute this value into the x, and then just find the y by simplifying. Okay, you see the arithmetic, and then we can find the value of y is negative 43 over 13. So therefore, the solutions of the system is, I want you to be careful, s equals in braces the coordinate. This is one coordinate, negative 15 over 13, comma negative 43, comma 13. If you notice, these both functions, okay, actually I take it from this one, this example, okay, except this one. So this is both functions, and we cannot find it by graphing. So by using the calculation, we can find that the solution or the ordered pair that satisfies both functions or this intersection is this one. Can you figure out? Can you imagine how do you find exactly this value by using the graph? Which is, yeah, it's almost impossible. So yeah, negative 15 over 13, which is negative 1 to 13. Yeah, it is negative 1 above something, yes. And then negative 43 over 13, which is negative 3 over 3 something, 3 point something. And then, yeah, this is the value is negative 3 point something. So that's how you use the substitution. The last thing that I want to introduce you on this video is I will show you three different cases a linear system can have. Okay, if we have a system of linear equations that consists of, for this one, let's focus on two linear functions, only two, not three, not four, not so, okay, just two. So if we have a system that consists of two different lines, two different linear functions, and they have different slope, they will obviously have only one solution, one intersection, right? So if this is the case, the intersection is here, only one. If I have another case like this one, we have one intersection. Even if I have this one, right? Since they have two different slopes, in the end, on that area, they will intersect each other. And you can be certain that there will be only one intersection. So there will be only one solution. So we have only one solution for this situation. This is called independent. Independent means we have two different linear functions which have different slope. So they will have obviously one intersection. They will have one solution. That is independent. The next case that we have is this one. If I have two different linear functions, but they are parallel to each other, you will be certain, since they are parallel, they won't intersect. They won't. Therefore, since there is no intersection, we have no solution. No intersection, no solution of the system. So whenever a system of a linear equations consists of two different linear functions which is parallel to each other, we have no solution. This case is called inconsistent. If we have inconsistent case, if we do the elimination or substitutions by calculation, okay, the last statement will be 0 equals other values, or 5 equals 3, 0 equals negative 5, 0 equals 6, which doesn't make sense. That's why we have inconsistent. Okay, the other one will be like this. If I have two lines, but actually they are exactly the same line, exactly the same. So these have two lines and they have exactly, they will just overlap to each other. It means the solution or the intersections will be the whole line, since they are intersect each other in all of the ordered pairs they have. So this case is called dependent. Dependent means the solution will be the line itself, since they are intersect each other and add all ordered pairs they have. So dependent case, if we are using not graphing, if you're using calculation by using the linear combination, we are using the substitution, the last statement will be like 0 equals 0, or yeah, 0 equals 0, or 5 equals 5. So we have a valid and true statement, which is 0 equals 0. So if that is the case, this is the dependent case. So if you want to figure out more about this, you have to do the practice. So that's the end of our video. Thank you for listening. Bye.